Sizing a home standby generator involves several key steps to ensure it can adequately power your essential appliances and devices during a power outage. It's crucial to accurately determine your power needs and select a generator that meets those requirements, while also adhering to safety standards. Here's a breakdown of the proper method for sizing a home standby generator. Firstly, you need to determine your critical loads. This involves identifying the appliances, lights, and other electrical devices that are essential for your home's functionality and safety during a power outage. These might include refrigerators, freezers, medical equipment, essential lighting, heating or cooling systems, and sump pumps. Create a comprehensive list of these critical devices. Next, estimate the wattage of each device. You can find this information on the product specification label, which is typically located on the appliance itself. Look for the wattage rating, which is usually expressed in watts. If the label only shows the amperage, you can calculate the wattage by multiplying the amperage by the voltage. In the United States, most household circuits are 120 volts. So, the formula is wattage equals amps times 120 volts. For larger appliances like air conditioners or electric stoves that use 240 volts, use that voltage in the calculation. Once you have the wattage for each critical device, sum up the wattage of all these devices. This will give you the total wattage of your critical loads. This is the minimum amount of power your generator needs to provide. Secondly, add a safety margin. It's essential to add a safety margin to your calculated wattage to account for potential surge currents and future expansion. Surge currents occur when certain appliances, like refrigerators and air conditioners, start up. They require a brief burst of power that is significantly higher than their running wattage. To accommodate these surge currents and provide some headroom for future additions to your critical loads, increase the total wattage you calculated by 20 to 25%. To do this, multiply the total wattage by 1.20 or 1.25. The result will be the recommended wattage capacity for your generator. Thirdly, consider backup time. Determine how long you want the generator to power your critical loads in the event of an outage. This will depend on the typical duration of power outages in your area, as well as your personal needs and preferences. If you live in an area prone to frequent and extended outages, you may want to consider a longer backup time. Estimate the runtime in hours. This is the number of hours you want the generator to be able to run continuously on a single tank of fuel. Fourthly, calculate fuel capacity. Generators are typically fueled by gasoline or propane. Gasoline is readily available, but it has a shorter shelf life and can be more difficult to store safely. Propane has a longer shelf life and can be stored in larger tanks, but it may require professional installation. To calculate the fuel capacity required, you need to know the generator's fuel consumption rate. This is typically expressed in gallons per hour for gasoline generators or pounds per hour for propane generators. The fuel consumption rate will vary depending on the generator's size and load. You can find this information in the generator's specifications. Once you have the fuel consumption rate, multiply it by the desired backup time in hours. This will give you the total amount of fuel required to run the generator for the desired duration. Choose a fuel tank that has a capacity equal to or greater than this amount. Fifthly, choose a generator. Select a generator that meets or exceeds the following requirements. The wattage rating should be equal to or greater than the calculated load plus the safety margin. This ensures that the generator can handle all of your critical loads, even during surge events. The runtime should be equal to or greater than the desired backup time. This ensures that the generator can power your critical loads for the duration you need. The fuel capacity should be sufficient to power the generator for the desired backup time. This ensures that you won't run out of fuel in the middle of an outage. In addition to these basic requirements, there are a few other factors to consider when choosing a generator. These include the type of electricity produced, the noise level, and the ease of use. Choose a generator that produces alternating current, or AC, electricity, which is compatible with most household appliances. Generators can be quite noisy, so consider a model with a noise-reducing enclosure if noise is a concern. Look for a generator that is easy to start, operate, and maintain. Additional considerations should include the type of electricity produced. Choose a generator that produces AC, alternating current, electricity, which is compatible with most household appliances. Transfer switches are also important. Install a transfer switch to safely isolate the generator from the utility grid during an outage. A transfer switch prevents backfeeding, which is a dangerous situation where electricity from the generator flows back into the utility grid. Backfeeding can injure or kill utility workers who are trying to restore power. It can also damage the generator and other electrical equipment. There are two main types of transfer switches: manual and automatic. A manual transfer switch requires you to manually switch between the utility grid and the generator. An automatic transfer switch automatically switches to the generator when the power goes out and switches back to the utility grid when the power is restored. Automatic transfer switches are more convenient, but they are also more expensive. Installation is also another important factor to consider. Hire a qualified electrician to properly install and connect the generator to your home's electrical system. Generators should be installed outdoors in a well-ventilated area. They should not be installed in garages or other enclosed spaces, as this can create a risk of carbon monoxide poisoning. A qualified electrician can ensure that the generator is installed safely and properly, and that it meets all applicable codes and regulations. When selecting a generator, you might also consider the starting wattage versus running wattage. Many appliances, especially those with motors like air conditioners and refrigerators, require a higher wattage to start than they do to run continuously. This is known as the starting wattage or surge wattage. The generator you choose must be able to handle the highest starting wattage of all your appliances that might start simultaneously. Look for generators that specify both their starting wattage and running wattage. Also, consider the generator's fuel type. Generators typically run on gasoline, propane, or natural gas. Gasoline generators are generally less expensive but require more frequent refueling. Propane generators can run longer on a single tank, but propane tanks need to be refilled or replaced. Natural gas generators offer a continuous fuel supply if you have a natural gas line, but they require professional installation. Also, think about the generator's portability. If you need to move the generator around, consider a portable model with wheels and a handle. For stationary setups, a permanently installed generator with an automatic transfer switch might be a better option. Also, consider the generator's features. Some generators come with features like electric start, remote start, and automatic voltage regulation. Electric start makes it easier to start the generator, while remote start allows you to start it from a distance. Automatic voltage regulation helps protect your appliances from voltage fluctuations. Maintenance is also important. Regularly maintain your generator to ensure it is in good working order. This includes changing the oil, cleaning the air filter, and checking the spark plugs. Follow the manufacturer's recommendations for maintenance. Finally, safety is important. Always follow safety precautions when operating a generator. Never operate a generator indoors or in a confined space, as this can lead to carbon monoxide poisoning. Keep the generator away from flammable materials and never refuel the generator while it is running or hot. By following these steps, you can properly size a home standby generator and ensure that you have reliable backup power during a power outage. Remember to prioritize safety and consult with a qualified electrician to ensure proper installation and operation. Choosing the right generator and installing it correctly will provide peace of mind knowing your essential appliances will function when the power goes out. Bear in mind that local codes and regulations may apply to the installation and operation of home standby generators. Check with your local authorities for any specific requirements in your area. The National Electrical Code, or NEC, provides guidelines for the safe installation of generators and transfer switches. Article 702 covers optional standby systems, which include generators used for residential backup power. Adhering to the NEC standards ensures that your generator installation is safe and compliant. When calculating your critical loads, it's better to overestimate than underestimate. This provides a safety margin and ensures that the generator can handle all of your essential appliances without being overloaded. Overloading a generator can damage it and reduce its lifespan. If you are unsure about the wattage requirements of your appliances, consult with an electrician or refer to the appliance's user manual. When considering backup time, think about the potential duration of power outages in your area. If you live in an area prone to severe weather events, such as hurricanes or blizzards, you may want to consider a longer backup time. This will ensure that you have power for an extended period in case of a prolonged outage. When calculating fuel capacity, it's better to have more fuel than you need. This will provide a buffer in case the outage lasts longer than expected. Store fuel safely in approved containers and follow all safety precautions. When choosing a generator, consider its noise level. Generators can be quite noisy, which can be disruptive to you and your neighbors. Look for models that have noise-reducing features such as enclosed mufflers or sound-dampening materials. When installing a transfer switch, make sure it is properly rated for the size of your generator and your home's electrical system. A transfer switch that is too small can overheat and cause a fire. When connecting the generator to the transfer switch, use properly sized cables and connectors. Poor connections can lead to voltage drops and overheating. When operating a generator, never overload it. Overloading a generator can damage it and reduce its lifespan. If you need to power more appliances than the generator can handle, consider using a larger generator or reducing your critical loads. When refueling a generator, always turn it off and let it cool down before adding fuel. Spilled fuel can ignite and cause a fire. When storing a generator, drain the fuel tank and store it in a dry, well-ventilated area. This will prevent the fuel from deteriorating and causing problems when you start the generator again. When maintaining a generator, follow the manufacturer's recommendations for oil changes, filter replacements, and other maintenance tasks. Regular maintenance will help keep the generator running smoothly and extend its lifespan. When using a generator, be aware of the dangers of carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. Never operate a generator indoors or in a confined space. Install carbon monoxide detectors in your home to alert you to the presence of carbon monoxide. Remember, sizing a home standby generator is a critical step in ensuring you have backup power during an outage. Taking the time to accurately assess your needs and select the right generator will provide peace of mind and keep your essential appliances running when you need them most. Following these steps and considering all relevant factors will lead to a safe and reliable home standby power solution. The information provided here is for general guidance only. Consult with qualified professionals for specific advice and recommendations related to your individual circumstances and local regulations. Understanding the concepts of voltage, amperage, and wattage is crucial for understanding how generators work and how to properly size them for your needs. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Amperage is the measure of the electrical current flowing through a circuit. It is measured in amps. Wattage is the measure of electrical power. It is calculated by multiplying voltage by amperage. For example, a 120-volt appliance that draws 10 amps consumes 1200 watts of power. Generators are rated in watts, which indicates the amount of power they can produce. When sizing a generator, you need to make sure that it can produce enough watts to power all of your critical loads. It's important to differentiate between running watts and starting watts. Running watts are the continuous power required to keep an appliance running. Starting watts are the surge of power required to start an appliance, especially those with motors. Generators typically have a higher starting watt rating than running watt rating. When calculating your critical loads, you need to consider the starting watts of appliances that have motors, such as refrigerators, air conditioners, and pumps. These appliances may require 2 to 3 times their running watts to start. Another important consideration is the power factor. The power factor is the ratio of real power to apparent power in an AC circuit. Real power is the power that is actually used to do work. Apparent power is the product of voltage and current. The power factor is typically expressed as a decimal between 0 and 1. Most household appliances have a power factor close to 1. However, some appliances, such as motors and fluorescent lights, have a lower power factor. When sizing a generator, you need to take into account the power factor of your appliances. If you have a lot of appliances with low power factors, you may need to choose a larger generator than you would otherwise. Automatic voltage regulation, or AVR, is a feature that helps to maintain a stable voltage output from the generator. This is important for protecting sensitive electronic equipment from voltage fluctuations. Generators with AVR are typically more expensive, but they provide better protection for your appliances. Some generators have features such as low oil shutoff, which automatically shuts off the generator if the oil level gets too low. This prevents damage to the engine. Another feature to look for is overload protection, which protects the generator from being overloaded. Overload protection can be in the form of a circuit breaker or a fuse. When using a generator, it's important to follow all safety precautions. Never operate a generator indoors or in a confined space, as this can lead to carbon monoxide poisoning. Keep the generator away from flammable materials and never refuel the generator while it is running or hot. Use properly grounded extension cords and never overload the generator. By following these guidelines, you can safely and effectively use a generator to provide backup power during a power outage.